Thanks everyone for taking the time to log in and hear this talk. This is actually I think this is the first proper kind of fully online conference I've been engaged with actually this year. So I'm excited by the format. And as Mirko said, I'm based in a geography department, so much of my interest is in geographical information, mapping, cartography, those kinds of things. And I guess I'm from a slightly different world to many of you in the sense that I'm kind of, I guess, further along in the user chain in the way that the data are utilized. So I'm not so engaged in kind of the back end necessarily, or the kind of more technical aspects of the data collection technology, but I am definitely a user of many different data sets, and primarily ones that are spatial data and collected via things like GPS and other mobile devices. So today I wanted to kind of give an overview of some of my thinking about how new and emerging technologies, and I was reflecting on this phrase actually. I mean, some of this work goes back a number of years now, and so actually the idea that these forms of data are new, or the technology is emerging, is probably actually a bit strong. I think we're now increasing at a stage where there's a fair amount of maturity in the kinds of technology and data that I've been looking at. But I wanted to go through some of the sort of thought processes that I have when I go about doing data visualization and mapping, and thinking about some of the data that I've been looking at. And the two kind of main sources, although there are others that I'll draw from, that this talk will touch upon are, as Mirko mentioned, two books. One's called London, the Information Capital, and the other, Where the Animals Go. And they both have a purpose, which is to take kind of new concepts, new ideas about data, and to share them with a very broad audience, the general public who would buy them as, coffee table books and gifts and so on. And throughout these projects, I co-authored them with a designer whose name is Oliver Uberti. And so he comes from kind of a media background, working at National Geographic magazine originally. And so it's an interesting collaboration we have, where we have to go through a series of kind of steps and thought processes in order to take what is often quite raw data, quite large data sets, and process and analyze them in such a way that they can be easily understood by a general audience. And so some of the examples I'm giving today will be very specific to, producing a book or an atlas or something like that that has a wide appeal. But principles that I'm talking about, the thought processes, the processing steps, the way that we conceive and think about some of these data sets, actually, I think, have important resonance with anyone doing work in this space with these kinds of data sets, who ultimately we're all producing scientific figures and graphics. And even when we're interrogating data visually, there are ways that we can look at this that enables us to get the most out of the data in a way that a broad range of people can understand it. So this isn't about kind of dumbing down or data reduction for its own sake. It's actually about how we can better communicate our findings. And so the talk really has kind of 5 different elements to it. So the first element is just a quick reflection on what, if anything, has changed in the way that we think about data and data visualization. And that change has been initiated by large data sets emerging, often real-time data in tremendous volumes. And then I wanted to give kind of 4 different kind of sets of reflections really about the data, how we represent it, the appropriateness of the the form of the representation that we take, so the kind of visual that we may choose, how appropriate it is, and how it can be improved or augmented with other data sets in order to make it a more compelling visualization. And then finally, I just briefly talk about kind of reproducible innovation and how actually I think one of the big kind of transitions we've gone through in the last few years has been some of these visualization techniques have become much more reproducible thanks to coding and code books and so on. So to take the first aspect, how has kind of new technology and the data, crucially, it produces kind of changed the way we do things? Has anything really changed? And my argument here is actually that data visualization has always been an act of distilling the complex world into a single image. And so every stage in the history of data visualization, and actually kind of the pioneers of data visualization sort of started in the 1830s, 1840s, it's been about taking an infinitely complex real world scenario and distilling it down into a single image, be that a chart or a map or a graph or something like that. And so actually big data, kind of new forms of data, haven't added to the complexity of the real world necessarily, but they have provided more raw material for us to work with in order to get that kind of message from the real world onto a page that can then be communicated with a wider audience. So the fundamental challenge actually hasn't changed, but the tools we use to tackle it, our available data and so on, they have changed. And cartographers are very fond of this fictional story by Borges, who talks about an empire that sought to create a map that was a one-to-one scale. So effectively, the aspiration was a map that would be as detailed as the Earth's surface itself. And they concluded that the only way they could create and achieve that aim was by a map that was one-to-one. So for every centimeter in the real world, the map, it was a centimeter on the map. And so it covered the empire in this one-to-one scale. And it fast became obvious that that was a very utterly useless way of using or creating a map. And the story ends with, in the deserts of the West still today, there are tattered ruins of that map, inhabited by animals and beggars. In all the land, there is no other relic of the disciplines of geography. And so it's really a kind of a warning about this idea that we can, ever be successful when we want to capture the complexity of the planet in a single visualization. So map makers, cartographers, data visualizers have always been adept at thinking through how you can take a very large data set and how you can represent it in an interesting and engaging way. And some of these pioneers have been kind of forgotten a bit, actually, in the work that we do today. And I'll reflect on that a bit later on in the talk. So the map I'm showing here is from a French statistical atlas. And the French government back in the 1880s, 1890s, and early 1900s actually had a statistical agency who created these atlases. And they took vast tabulations of data from the emerging transportation systems across France, in particular, and created early flow maps that showed passenger flows in this case, but also the nature and type of tickets, the revenue generated, flows of industrial goods, but also other examples. They did, for example, the audience numbers in theaters in Paris. You know, they took all these interesting data sets that you could think of as having modern analogies today through, you know, Foursquare data, check-ins, and mobile trajectory information on transport, and they created their own kind of compelling visualizations from the data that was available to them at the time. And the way that these representations took off, actually, that they were widely used and copied around the world. So this actually is an image from a parliamentary report that was created in 1911, that was a traffic census of flows of traffic into central London. And you can see here that, again, these kinds of flow lines, these variable width lines, were being used to represent that data set, which, you know, is the way the data was collected was clearly much more labor intensive. You know, it required people to go out and physically count passing vehicles. In addition to that, it required a tremendous amount of manual tabulation to create the final flows. But actually, the process and the objective is unchanged today. If you were taking a data set that contained a large number of trajectories and trying to aggregate those in such a way that we can create an informative visual from that. And so one of my kind of you know, places of the internet that cartographers or map makers love to hate is this Reddit page called Map Porn. And I encourage you, all of you, to check it out if your institutional filters allow. It's got hundreds now, I think, if not millions of, hundreds of thousands, if not millions of users on this Reddit page. And the thing that frustrates kind of those in the business of data visualization often is the fact that the most popular posts tend to be pretty poor visualizations of quite complex data sets. And so this was from a couple of years ago. I don't know if these two visuals are still the most popular, but they were for a time, where you had a mobile phone. You had mobility data recorded from biologging devices. So these devices effectively had a GPS chip and a mobile SIM card in them, and that data was conveyed to kind of the researchers that way. In the purple on the left, we've got the tracks of an eagle over a 20-year period. And then on the right, we've got the tracks of 6 wolves in, I think they're in Slovenia, actually, or at least they're in Central Europe. And what you can see here are two fairly sort of rudimentary maps. The lines are quite jagged, particularly for the wolves. There's not been much filtering or much thought that's gone in. And they break a lot of the rules, but actually they really resonate with the users of Reddit who've upvoted them, because they can tell a kind of a clear story. They convey one message each. You know, on the left, it's the fact that this eagle was able to, well, one, that it lived for 20 years, and two, that it went on these enormous migratory journeys from Sudan up into Kazakhstan. And then in the case of the wolves, it's just a very clear idea that, you know, each wolf has its own territory, and there's very little overlap between them. So it's a very simple message. And, you know, as I say, sort of from someone who's interested in data visualization and mapping, you kind of get a bit fed up, because you think, oh, you know, I've worked on these things, and we'll come on to my versions of these kinds of graphics in a minute. You know, I've invested a lot in this to add a richness of detail that these depictions don't have. But that doesn't necessarily make them any more interesting or engaging for a very kind of rapid consumption online. So this is just a reminder, really, that I'm not, we don't expect every visualization that people do to kind of be perfect, and actually sometimes imperfect ones can be quite compelling and engaging. But there are certain things that we can do and things we can think about in order to add further context. So just to give you a couple of the kind of counterexamples that I have. So this is one of a single journey of a single wolf named Slump, who was quite famous in Slovenia because he went on this 1,000-kilometer journey through Austria into northern Italy and eventually settling in Lucena Regional Park. And in this case, it was a GPS tracking collar, and the researchers were following in real time, and they were very savvy in the way that they used the media on this particular journey. So every time the wolf arrived in somewhere, kind of in a particular locality, a village or a ski resort or something like that, they did alert the local media so that people could look out for it and almost sort of protect it, because they were concerned that it would be shot by poachers and so on. But where this map is different from, it's a really brilliant story, but where this map is different from, the ones that I showed previously of the wolves, is that we've got more contextual information on there. We've got a bespoke kind of layer of terrain information. We've got a contextual map that shows the distribution of wolf populations. And crucially as well, we've got this sense of story, of narrative, by adding labels, adding directional arrows and so on, to help guide people through that particular journey that the wolf is taking. And so the addition of just a few labels can actually make a very big difference in the way that people can kind of get in and understand and the detail they can get out of the map. This second example I've picked to sort of contrast with that of the Eagles map, the eagle that I showed, because again, it demonstrates how we can add lots of extra layers of data to kind of augment what we're showing alongside some of that trajectory information. So in this case, this is showing the journeys that Arctic terns take. And these birds fly tens of thousands of kilometers, and because they're so small, conventional kind of GPS is too heavy, or so they use very tiny light loggers that are strapped to the legs of the terns. And these light loggers are quite crude. They give a very brief sort of crude location based on daylight hours and angle of the sun and so on. However, they are able to give enough data for these very, very long journeys. And what we were able to do is take information about ocean productivity, take information about ocean currents, and actually use them as the base map in order to help explain what the birds were doing in any given location. So why is it that they're stopping off the east coast or southwest coast of Africa? Well, that's an area of very high ocean productivity. It's an area where there's plenty of food to eat, and so that becomes a staging area. And so we're able to add some of that interesting context for people to look at. So we've got more data and more availability for some of the technology and stuff to visualize it. So I just wanted to, again, look back at some of the kind of rhetoric and thinking that was going on, in this case in 1964, about tremendous volumes of data that were needed or were available in order to get detailed social studies. And so this is from quite an iconic book called The Structure of London. And J.H. Westergaard here is talking about the need for more detailed data. And he's saying that such differences could only be revealed if we had comprehensive data for small, homogeneous urban areas of the kind which will in fact become available for the first time in the census of 1961. So they're tremendously excited about the idea that we can have more detailed data. And effectively, these are the kinds of maps that they were excited about and generating at the time. And you can see that these are, for those familiar with London, these are still incredibly large areas that the data are pertaining to, that the insights correspond to. And yet this is considered sort of big data, sort of a major innovation to be able to group together people into these areas. Of course, now we're doing it at, the level of precision, which is a single individual. But we're still talking about, the excitement of these large data sets. So the perception, at least, of big data has always been with us. And what slightly got lost is the way that we can visualize some of this data so that it can continue to be informative whilst still kind of capturing the volumes of data involved. So on the left-hand side here, I've got an example of a dot density map, it's called, where effectively a single dot is placed on a map to represent an individual. And these are increasingly popular. Actually, a version of these are now appearing in, particularly in the US media, to show COVID-19 deaths. And so we have kind of a high density of points. But the problem is, on the left, you can see that in urban areas, particularly in London, with higher populations, they get completely saturated. So what you have is an effect where you get a solid black color, where actually there's just lots of dots. And then because of the way that the dots are allocated kind of randomly, they're dropped within a given area. Those of you familiar with London geography will see that there are certain parks here that actually have got dots in them. Hyde Park, Regent's Park, up in Hampstead Heath, and so on. And these parks actually, no one lives there. And so you're giving this idea that there's some kind of false precision, that you're assuming that there's individuals' characteristics, social characteristics that apply to them. On the right-hand side, we have a dot density map, but this time it was produced for an atlas called the Atlas of London, and it was produced in 1968. And straight away, you can see that the parks, Hampstead Heath, Regent's Park, Hyde Park, and so on, and the Lee Valley, which is an area of open land and industrial units, that doesn't have dots in it. And there are fewer dots as well. And so you can see more of the structure. And if we look at the caption that accompanies the map, you can see here that the dots here have been closely related to residential land use, avoiding not only open spaces and parks, but also the more extensive areas of industry. And so the big difference between the map on the left and the map on the right is the dot density map, the black one, was produced automatically, computationally, using a computer, where it was a couple of lines of code to generate the dots and to scatter them. The one on the right in 1968 was drafted by hand. And so, of course, the people doing that had more time and probably put more thought into, well, let's put these dots in places where we know where people live, rather than just for the sake of it, create a very high density, sort of saturated map. And that's something that we can think about in the way that other more complex data sets are shown today. So this was a very popular map. Apologies, it doesn't seem to be rendering properly on my screen. But this is a popular map that was created of global migration flows, where you had these dots flying from one place to another. But the problem is they actually are less informative actually than you might think. If you start interrogating them and asking questions about, well, how many people are flowing from one country to another, And so they're very effective at demonstrating high volumes of data, but less effective at demonstrating kind of what the patterns of the flows are. And so this is a map that was produced by Minar in 1858 that shows migration flows. But you can see here that it actually forms the inspiration for the migration for the flow maps I showed you at the beginning with the French Transport Atlas. But you can see here that some thought has gone into sort of pulling out the flows, providing some structure. And actually, it's very easy for a reader to establish what the dominant flows are, what the minor flows are, and actually to kind of follow those flows from one country to another in a way that the Metrocosm map is much more challenging to do. And as I said, you know, these maps provided some inspiration for the French transport atlases, which then provided inspiration for kind of global transport atlases. And this is a zoom in of the earlier map I showed you of London, which is showing in red and pink. I think red is trade vehicles, so effectively commercial traffic, and pink is non-commercial traffic. And so thinking about the data and the complexity means that you can actually reduce it down into some interesting and compelling stories just by some data reduction and also some creation of metrics and thinking about the storytelling. So this is a chart that was created from several billion data points in the end. It was showing activity levels in bike share schemes around the world. And these were collected at 2-minute intervals and over a long time period. And so we have tremendous volume of data. But actually the story, or the thing that we were trying to tell was, you know, which areas have the most successful schemes, which areas have the least successful schemes, and which schemes have shown kind of improvement or decline in their usage. And so to tell that story to a newspaper audience, we had hundreds of schemes to choose from, but we only selected 10 or so that were then captioned and labeled and showed at 2 time points on a given metric we were using. And so it makes it much more accessible, much more informative. The main data is still there, but we're just extracting some of the key elements from it. So how has representation changed, or how effective are we now at representing some of these big data sets? And so this touches on some of the things I was saying just now about the migration flow map and the Metrocosm map. Are we doing a better job now of telling stories with these larger data sets compared to, you know, the work with smaller data that's happened, you know, in the century or century and a half to this point? So this is a really nice map to look at. It's showing, I think, over 1 billion points, which are generated from the New York taxi data set. And effectively, it shows a map of New York roads, and it shows that sort of downtown Manhattan has a higher number of taxis, and, you know, the airports also kind of have high numbers of taxis. It doesn't really tell us much more than that. You know, we probably knew that if we had to draw a map, you know, if we had to imagine what this map would look like, we would know what it looked like. We could guess that Manhattan and the airports were probably the most popular places for taxis. And so I'm keen that we start thinking a bit more about, okay, on one level, we want to reveal how much data we have, but on another level, we do have to start thinking about what the kind of levels of insights we're able to get. And this can slightly backfire. This is a famous example now, I think, from Strava in 2018, where they were taking the trajectory data from their users. They combine it into a single world map called a Strava heat map. And I think the Strava engineers are based in California, I think San Francisco, and they were optimizing their visualization to show patterns within urban areas. I guess they were looking in their neighborhoods and trying to kind of extract as much of a pattern as possible whilst preserving sort of the privacy of their users. And so they created a series of kind of rules in their visualization algorithm that worked very well for urban areas, but no one thought to look in the places or the parts of the map where actually there are very, very few users and what those impacts may be on those areas. And so they accidentally outed a whole load of US military bases in particular. Here's a few around Kabul, where the US military had effectively given their soldiers some of these smartwatches, which they then plugged into the Strava fitness app. They didn't turn off the location sharing. And so even though there may have only been a few runs that were happening, they were being uploaded into Strava, and then Strava was working because they wanted to show patterns on the map. They kind of really, in the rural areas, they kind of massively exaggerated them. And so you have these military bases that kind of shone out in all kinds of parts of the world. And Strava got into a lot of trouble with this from the US military, but I think it's probably, more a conversation they should have been having with their soldiers on deployment about location technologies and how to preserve privacy. And actually, we were one of the first to create similar maps for, in this case, we did it for London back in 2013 when Strava were just starting out. And what we were trying to reveal there was not just where people run, but also what the kind of different patterns were in usage of weekday versus mornings versus afternoons versus weekends, and so on and so forth. Here's a kind of another kind of innovative platform, Kepler, which I think it may be something else now, but it was a big data visualization platform developed by Uber. And you can create these kinds of brilliant visualizations very rapidly, which, again, are brilliant at revealing or surfacing how much data you may have in your data set, but arguably much less informative when it comes to the users extracting any kind of meaning from them. And so you can get some improvements through interactivity. So this is a kind of tooltip where you can scroll through and look at the extent of the flows into an area using that technology. But again, it's very hard for a user to kind of quantify exactly what's going on here. So our version of the same data that was in that first Kepler map is this one, where we haven't bothered with the 3D or anything like that, but we've just pushed it down as a 2D map, but we've added labels, and we've worked hard to establish that the kind of the primary flows are the ones that shine through. And we're able to add additional context, a couple of pie charts showing the commuting times into London and so on. And so the data is the same, but the amount that's being surfaced in the visualization is probably a bit less for the map I'm showing now than it is for the Kepler one I showed you. But actually, in terms of the information that's conveyed to the person viewing the map, there's actually a lot more. And so, this is created with the aid of a sort of, Oliver, who's a designer, and so none of those of us who don't have a design background or expertise, we may not aspire to be able to create graphics that are as well designed as this one, but we can pull out some of the key features, which is not being too worried about the kind of gimmicky elements of 3D, but also adding labels and information. And this is actually just a really nice, simple animation of flows that my colleague Oliver O'Brien did back in 2012, which is showing the flows in inputs and outputs of the London transport system when that data first became available. So it's a nice, at the time it was considered quite a pioneering visualization of this data, nice red and green color palette. But then when I was scrolling through my Atlas of London, actually a very similar, cartographically anyway, slightly different data set, but again, a similar depiction here of travel times into London was created. And most interestingly is the travel times haven't changed since 1968. In some cases, it actually takes more time to travel into central London today than it did back then. But again, it's just a reminder that the innovation actually in terms of the way that we visualize things is not as pronounced as we might first think when we look at some of the new maps and visuals out there. So the penultimate part of the talk is looking at the kind of the appropriateness of the way that we visualize some of the data we have. And so going back to these two, I would say that this visualization, these maps are wholly appropriate for the kind of data that is being depicted, or at least the forum that it's being shared with. It's a quick fix on the internet, and it works well for that. But are there other ways we can begin to take inspiration from historic data visualization and begin to pull it in to more contemporary data sets and then create something that's actually much more informative? And so I've got some examples here of that. So on the left is our historic example. This is from the Reader's Digest Atlas. It's on the front cover of them. It's embossed in gold, and it's showing the ocean currents. The contemporary version, although this is showing wind, although again it looks very similar, is the earth.nullschool.net website, which is a brilliant live animation of weather data. So taking inspiration from these two things, how can we, create our own layers that help tell a story? So this is kind of a vector field that I created of wind data going around Antarctica. So you can see Antarctica in the center here, and the wind's going round it. And these curves here are where they hit South America. And the reason I went for this and did this was because we needed to provide some contextual data for tracking trajectories that were collected by albatrosses that were circling Antarctica. And in this example, the researchers who had collected the data had never actually paired it with visualization of the wind. So they knew that in the case of the birds, the wind is incredibly important, and the biologgers that they had revealed that, but they didn't. They had never really put the two together in this way. And so what I think is a brilliant innovation, particularly for any of us who are using kind of trajectory data or data that's collected in real time, it's starting to think about extra base layers that can help explain some of the behaviors that we're seeing, particularly in our own work, but also to the readers who are looking at them. So in this case, we just wanted to explain to people why the albatrosses take the routes they do, and you can and why their fastest speeds occur. It makes sense that they occur where the strongest winds are, but you don't see that without the wind data. And another key part of the story is that there's a kind of a breeding colony here, and if an albatross gets as far as the Kerguelen Islands, they can't, or at least if they go past that, they can't get back to their breeding colony. It's more efficient for them to go all the way around with a tailwind. And so again, we're trying to explain that to people. Another example of sort of contemporaneous base mapping, which help explain a story, is from quite a large data set that shows the trajectories or movements of snowy owls over the Great Lakes. And in this case, the researchers were interested to see that owls were spending a long time over the lakes. Now, if we'd taken the kind of the Google Maps approach to this, none of these lakes would have been frozen, and you wouldn't have been able to see what the animals were doing. But in fact, we were able to take satellite image from the period that the owls were over the lake, and you could actually see the individual blocks of ice that the owls were spending time on, and then the areas of slightly more open water that they were using to hunt waterfowl in. And so a massive change, particularly in map making visualization in recent years, has been this idea that we can actually take real-time data and combine it with some of the sensed data on the ground. And another example of doing that was data about these small birds called warblers that researchers were able to show moving out the way of the path of some tornadoes. So these birds sort of detected these tornadoes a day or so ahead of their actual arrival. It was a band of big storms coming across the US. The birds retreated back down their migration route. The storms passed over, and then the birds returned to where they should have been. Real-time weather data combined with this trajectory information is really has really made a big difference. And you can see the biggest, I think, changes on the front pages of newspapers, particularly in North America. Actually, we saw it last week with the cold weather, where they're now taking satellite and remotely sensed data and pushing it straight into their front page in such a way that you look at it and you don't realize it's a live updating map. But this is an example that's sea surface temperature data that's from NOAA that they're using. There are other examples from hurricanes where it's rain accumulation rates and so on. And so now we're getting to a point where kind of traditional cartography and data visualization of the kind that I've been thinking about and talking about in this talk, we're now getting to a stage where the quality of those visualizations are now being combined with real-time data in kind of the wild, in the media and so on, and in such a way that the general public are consuming it without necessarily realizing that they're consuming that kind of data. And so with those innovations, I think that reproducibility is incredibly important. And I just wanted to end with this example of, this is a hologram, which was one of the first examples of an animated map. It was produced in the US, I think by the Harvard lab, and I can't remember the exact year that this was created, but it's a rotating hologram, and it shows three-dimensional lines for US population over time. And I was inspired to use this kind of approach when I was asked to create a map for the front cover of a conference way back in 2013, and showing population data. And the resulting map looked like this, and it took, there's talk of it taking inspiration from sort of the famous sort of Joy Division album cover, and it became quite a popular way of visualizing certain data sets. And it had the real advantage that it was entirely created in R. So it was a kind of reproducible map, which meant that I could very quickly create a version for London, which is on the left, or even quite recently, we were commissioned to create one for the Museum for the City of New York on the right. And so, the innovation, of course, with the programming is that, we just have to change a couple of parameters and away we go. But I think one of the best things we can all do is share code. And so I put my code online, but then many other people created versions of these maps in proprietary software like ArcGIS, but also in Python, in other visualization libraries. And so it's very quick to create your own versions of these kinds of visualizations. And that's something that I've definitely seen an acceleration in recent years. So when we first did the London book in 2012, 2013, it was probably 5 years or so before people started replicating some of the visualizations in that. So that commuting graphic, for example. Whereas now with the animals book and other work I've been doing, it's actually a period of weeks where someone has seen what we've done, taken the code, made a reproducible version of it, and even integrated it into sort of different packages and different software. And so the tools exist now to be able to create these visualizations. And if you have innovations, I think it's great to share them because others will pick them up and run with them as well. And so I just wanted to leave you with a kind of final thought, which is, I guess, the take-home message from what I've been saying, which is thinking about how visualization integrates with your data processing and analysis. And often we have these as two separate cycles. So we have data processing analysis, we do that. And then we think, right, now we've got to put it into a figure for a paper or something like that. And so we then go through the visualization loop. Was actually, if you look back at how some of the historic examples were created, but also the work that I do and others, is the processing analysis is part of the visualization. And so that integration should happen all the time, where you're processing data in order to optimize the visualization, rather than trying to make the visualization fit the way that you've processed some of the data. And that way of thinking makes a really big difference in the way that we create graphics and the way that they can be perceived by a wider audience. And here's just one example of that. So this is, I think, a week of flights from ADSB data, and it looks like this if you plot it in its raw form. And so you create a whole load of processing, and you can clean it up, and you get something that looks a bit more like this if you filter it out. And for most people, I think that would be the end point, and zooming in a particular area. But then, it's now possible to take it one step further, start thinking about how you can extract more patterns and representations from the data. And really, this is about filtering, about generalization, and about kind of cleaning as an integral part of the visualization, rather than viewing it as a kind of series of isolated steps you do first and then you visualize it. To get from this to this actually took quite a few incremental going back throughs and optimizing the visualization, even for the size of the page. So that's everything. I want to say thank you to Oliver, who I've worked with a lot, my colleagues at the Department of Geography, and then Mirko and the organizers of this conference. And by all means, get in contact or get in touch if you have any further questions you wish to ask. So thank you all for your attention.